Okay, we're on. This is video number 57. This is a pretty short video, Mrs. Les. We're going to talk about the slope of a line. All right, you ready?
Okay, sure.
Here we go. So,
Let's do it.
our very first slide. So, there we go. So here we have a line and we have several points marked. And it turns out that if any two we picked, we drew a slope triangle, turns out that the slope will be the same as long as we reduce it. So that's a property of lines, that any 2 points you pick, slope is going to be the same. All right, so we're going to show that that's true here. So this is the same line. You see we have 3 slope triangles, blue, red, and kind of gold color. And we're going to show that it doesn't matter which one we use, the slope will be the same. So for the blue one, the rise is 3 and the run is 2. So that one has slope 3/2. Okay. How about the red one?
Okay, so let's take a look at the red one. So the red one, what's my slope here? So here's my rise. I go 2, 4, 6, 8, 9.
You have better eyes than I have.
2, 4, 6, 9/6.
So you might say, wait a minute, that's different, but if you reduce 9/6, it reduces to 3/2. Okay, what if we use the gold one?
For the gold one, so let's count again. So 2, 4, 6, 8, 10, 12, 14, 15. And for the bottom, 2, 4, 6, 8, 10.
All right, so 15/10. But that too reduces to 3/2. So if points lie in the same line, they have the same slope. All right, so any 2 points on the same line, it doesn't matter. Now, one thing I want to point out, the reason why is these triangles are not congruent, but they are similar. And that's a property of similar figures. We'll see that later. But could you circle the 3 and the 2? If you take the ratio of the sides of similar figures, the ratios are the same.
Always the same.
So the lengths are the same. So 3/2 equals 9/6, which equals 15/10. So the reason why this is true about slope is because of similar triangles. All right, so let's see what we got next. So here is last we got P, Q, and R. They definitely do not lie on the same line. And as you can see, the slopes between them are different. Okay, so when points aren't on the same line, then when we calculate the slope, it's not the same. So that one is what?
So for the first one, PQ, and you could do either triangle.
Right.
Okay, so on this side from my rise, I have 4 units.
Right.
And I have 2 units for the run. So the slope, it's positive, and it's 4/2, which simplifies to 2.
Right.
And now
Q and R?
So for the second triangle, my rise is 2, and the run is 6. So this one, 2/6, which simplifies to 1/3.
So since the slope is not the same from P to Q and from Q to R, we know these points don't lie on the same line.
Right, so we say they're not collinear, or
Okay.
non-collinear.
So here's a little challenge. So we're given 3 points. We got to decide if they lie on the same line or not. So how are we going to do that?
So we're going to check. If we pick any pair, will they give us exactly the same slope?
Right, so we can do A and B, and then we'll do B and
so
C.
let's start with A and B. Okay, so let me get my pen here. Okay, so again, I would label the points for myself really quickly. X1, Y1, X2, and Y2, and figure out the slope. So for the first set, okay, remember the formula says Y2 minus Y1, or 2 minus 6, over 5 minus and -4. Again, be careful with those negatives. Okay, so we end up with -4 over 9 in this case.
Okay, and that doesn't reduce. So now we want to compute the slope between B and C. And if it's -4/9, they're collinear. That means they lie on the same line. Okay, so we get 14 minus 2. And -13 minus 5. So I think it's 12 over -18. And if we reduce, we can divide them both by 6, that'd be -2/3. So the slope changed. it's not the same between the first 2 points as the last 2 points. So these are not collinear.
So let's write this down. Not collinear.
Let's see if we have better luck this time.
Okay, because we have different slopes. Okay, so for the second one, so let's do PQ first.
Sure.
So M. Okay, so for the first one, I have 38 minus 30 over 23 minus 17.
Okay. So that's 8 over 6. And that reduces to 4/3. Okay. The last one, wow, that's kind of a crazy number here. So 1,450 seems crazy, but we'll go with it. Minus 32.
38.
Oh.
Are you doing
Oh,
Q?
yeah, 38,
Q, R?
38.
Yeah, so R is 38. Maybe
And
write it
then-
down here.
Okay.
The second one.
And that'd be 32 minus 23. I'm
Okay,
thinking there's
so
no
what do
way.
we get for the numerator?
We get 1,412. And the bottom we just get 9. There's no way this is going to equal 4/3.
No, that's why it
Divided by 9, it's way different. Yeah, we get 156.8. So,
these are again not collinear. Did we make a mistake on the first one?
I think I made a mistake on this last one. Our math is good, but I don't think I meant it to be 1,450. But that's the way it works. You just check the 2 slopes, reduce them. If they're the same, the points lie on the same line. If they're different, they're not collinear. So we ended up with 2 examples of not collinear.
Okay.
All
So
right.
not collinear, different slopes.
Yep. I was hoping one of them would be collinear. All right, that was a lot of work, but we just got confused slopes. Okay, here we go. Here's the journal assignment. I want you to find the slope between the following points, between C and D, B and E, A and F, and reduce them. Okay? Then, I want you to explain why all the slopes are equal to each other. So that's a big hint. They're supposed to be equal. So find out what they all are and explain why they're equal. All right, we'll see you next time.
Good luck.